Students, welcome to our YouTube channel Naraj Academy. In this lecture, we are going to basically discuss about the Laplace transform formulas in a very detailed manner. So basically here, the Laplace transform. So you can see clearly the Laplace transform of f of t is equal to, which is capital F of s is equal to integration of t is equal to 0 to infinity f of t into e to the power of minus st into dt. This is a basic formula of converting any time domain into a frequency domain, which is the Laplace domain. So therefore we can say the Laplace transform of f of t is equal to f of s is equal to integration t is equal to 0 to infinity f of t into e to the power of minus st into dt. So now we'll discuss some of the important properties of this Laplace transform. So the Laplace transform of a into f of t plus or minus b into g of t is equal to a into Laplace transform of f of t plus or minus b into Laplace transform of g of t. So whereas the Laplace transform of e to the power of minus at into f of t is equal to f of s plus a, means, or simply we can say the Laplace transform of e to the power of at into f of t is equal to f of s minus a. So whenever there is a e to the power of minus at means you have to go for the s plus a, otherwise e to the power of plus at means we have to go for the reverse process, which is the f of s minus a. So the Laplace transform of f of at is equal to 1 by mod a into f of s by a. So there is small correction here, this is the mod a. You can see clearly here the Laplace transform of f of at is equal to 1 by mod a into f of s by a. And similarly the Laplace transform of f dash of t is equal to s into f of s minus f of 0 minus. Plus Laplace transform of nth derivative of f of t is equal to s the power of n into f of s minus s the power of n minus 1 into f of 0 minus s the power of n minus 2 into f dash of 0 minus. So like that still we have to go until we are going to get a this is the power of 0. And similarly the Laplace transform of integration of 0 to t f of u du is equal to 1 by s into f of s. Whereas the Laplace transform of t to the power of n into f of t is equal to minus 1 over the power of n into, then we have to go for the nth derivative of f of s with respect to s. See, n is going to go from 1 to up to infinity. So therefore n can be any value. So this is the general formula of the Laplace transform of t to the power of n into f of t is equal to minus 1 over the power of n into nth derivative of f of s with respect to s. If you want to know what is the Laplace transform of the 1 by t into f of t, which is integration of s to infinity f of s into ds. So these are the very important formulas, because if you remember this one you can easily solve the questions based on the Laplace transform. U of t minus a is nothing but it's a unit step function. It is equal to 0 for t less than a, but it is equal to 1 for t greater than or equal to a. And if you want to know what is the Laplace transform of f of t minus a into u of t minus a is equal to, see, whenever there is a delay in the function f of t by some small amount of a, then it will become e to the power of minus as into f of s. So Laplace transform of f of t minus a into u of t minus a is nothing but e to the power of minus as into f of s. So now we are going to learn some of the two important formulas in Laplace transform, which are the initial value theorem and the final value theorem. So the initial value theorem, which is, I want to know what is the initial value of the function f of t at t is equal to 0. So therefore limit t tends to 0, f of t is nothing but f of 0 plus t is equal to limit s tends to infinity s into f of s. So you can go either for this process or either in this process. So therefore you are going to get the initial value of the function. But if you want to know the final value of the function, which is f of infinity or limit t tends to infinity f of t is equal to limit s tends to 0 s into f of s. So no matter in whichever the process, whether you go for the time domain or whether you know the Laplace domain, and you can substitute these values to get the value of the initial value and the final value of a function. So we are going to call this as the initial value theorem and the final value theorem. So therefore limit t tends to 0, f of t is nothing but f of 0 plus is equal to limit s tends to infinity s into f of s. And similarly limit t tends to infinity f of t is nothing but f of infinity is equal to limit s tends to 0 s into f of s. See, the final value theorem is going to apply only when, the final value theorem is going to apply only when the system is stable, otherwise we are going to get infinity. So before applying this one, you should check whether the system is a stable system or an unstable system. But the initial value you can apply for any function, but the only special condition for the final value is the system should be always stable. Then only you can apply the final value theorem. See, the system is stable only when the poles are going to lie in the LHS but not in the RHS, because if the poles are going to lie in the RHS, then definitely we are going to have increasing exponentials, means the transient will always going to get increase. Then we can say always they are not going to get any stable state, they are always going to increase. But if the poles are going to lie in the LHS of S plane, then definitely we can say that the transients are going to get die as the time goes on, and finally the final value will be equal to the steady state value. Then we can say that the system is said to be a stable system. I will discuss some more important formulas of Laplace transform, which is the Laplace transform of 1 is equal to 1 by s, and the Laplace transform of t to the power of n is equal to n factorial by s to the power of n plus 1, where n can be 0, 1, 2. These are basically a positive integers. So therefore we can say, suppose if you substitute n is equal to 0, we are going to get the above one, which is the Laplace transform of 1 is 0 factorial by s to the power of 0 plus 1 is nothing but 1 by s. You are going to get the above function. And also the Laplace transform of e to the power of at is 1 by s minus a, or we can say simply the Laplace transform of e to the power of at will be 1 by s minus a. And similarly the Laplace transform of e to the power of minus at will become 1 by s plus a. And if you want to know the Laplace transform of the sin at, which is a by s square plus a square, whereas the Laplace transform of cos at will be s by s square plus a square. Whereas the Laplace transform of sin h of at, see, just you have to go for this one, in place of plus, replace plus by minus, and remaining thing is same as this one. So therefore a by s square minus a square. And the Laplace transform of cos at is nothing but same as the Laplace transform of the cos h of at is the same as this value, but only thing is replace plus by minus. So you are going to get this value, which is s by s square minus a square, and remaining everything is same. And now I have already told you the Laplace transform of e to the power of at into f of t is equal to f of s minus a. So therefore we can say, see, this value is the Laplace transform of t to the power of n is n factorial by s to the power of n plus 1. So now replace s by s minus a, you are going to get this expression, which is n factorial by s minus a whole to the power of n plus 1. So these are the applications of the Laplace transform of e to the power of at into f of t is equal to f of s minus a. So now sin bt is b by s square plus b square, but here we are going to replace s by s minus a, so we are going to get this expression. And similarly the Laplace transform of cos bt is s by s square plus b square. So therefore now here there is a e to the power of at, means replace s by s minus a, so you are going to get s minus a by s minus a whole square plus b square. And similarly the Laplace transform of sin h bt is b by s square minus b square, but there is a term which is e to the power of at, so replace s by s minus a, so we are going to get b by s minus a whole square minus b square. And similarly the Laplace transform of cos h bt is here s by s square minus b square, but now there is another exponential term which is e to the power of at, so replace s by s minus a, so we are going to get s minus a by s minus a whole square minus b square. So these are some of the important formulas which are regularly important in solving the Laplace transform questions. Transform of 1 by 2at sin at is nothing but which is s by s square plus a square whole square. So now see how to solve this one. I have already told you, which is the Laplace transform of sin at value we know. Then the Laplace transform of t into s of sin of at, I have already told you the basic formula, which is Laplace transform of t to the power of n into f of t is equal to here minus 1 over the power of n into nth derivative of f of s with respect to s. So by using that formula you can solve this equation, and finally you are going to get which is s by s square plus a square whole square. And similarly the Laplace transform of 1 by 2a cube sin at minus at cos at, yes, you can go for the same previous method, and finally if you do this one we are going to get 1 by s square plus a square whole square. Suppose now we are going to learn suppose if a function is a periodic function, if a signal is a periodic, then how to figure out the Laplace transform now we are going to learn, which is suppose here f of t plus capital T is equal to f of t, means we can say simply this signal is going to have a time period of capital T. Then how to figure out the Laplace transform of a periodic signal, which is f of t is equal to 1 by 1 minus e to the power of minus s capital T into, we have to do integration only with respect to one time period, which is 0 to t, and f of t into e to the power of minus st into dt. So this is same as the previous one. The only external factor we need to multiply, which is 1 by 1 minus e to the power of minus s capital T, and we have to do only integration for only one time period. So in this way we can figure the Laplace transform of any periodic signal. And similarly the Laplace transform of t into e to the power of minus 80, which is 1 by s plus whole square. So I have already told you that Laplace transform of t is nothing but 1 by s square, but there is another term which is e to the power of minus 80, so replace s by s plus a, so we are going to get this expression. So only thing is, if you know the basic formulas, now you can do the simplification to get any Laplace transform of any odd function also you can easily figure it out. So now we learned about the Laplace transform formulas, but now we are going to learn about the inverse Laplace transform formulas. Now we are going to learn, which is the Laplace inverse of 1 by s is nothing but 1, whereas the Laplace inverse of 1 by s to the power of n is e to the power of n minus 1 by n minus 1 factorial. And the Laplace inverse of 1 by s minus a is e to the power of at. And similarly, the Laplace inverse of a into f of s plus or minus b into g of s is equal to a into Laplace inverse of f of s plus or minus b into Laplace inverse of g of s. Similarly, the Laplace inverse of f of s is equal to f of t, and here these are the conditions it must satisfy, which are the f of 0 minus is equal to f dash of 0 minus is equal to up to f to the power of n minus 1 0 minus is equal to 0. If these are the conditions satisfied, then only we can say that the Laplace inverse of s to the power of n into f of s is equal to d nth derivative of f of t with respect to t. So see, if these conditions are satisfied, then only this will converge to this value. And similarly, the Laplace inverse of f of s is equal to f of t. Then what is the Laplace inverse of f of s by s cube? See, 1 by s is nothing but it's the integration for one time. So if you are going to do for 3 times, means we have to go for the 3 times of integration, which is 0 to t, 0 to r, 0 to m, f of t dm dr dt. And similarly, the Laplace inverse of s to infinity f of s ds is nothing but f of t by t, because I have already told you the Laplace transform of f of t by t is nothing but integration of s to infinity f of s into ds. So if you do the reverse process, we are going to get this equation. And similarly, the Laplace inverse of d and the derivative of f of s with respect to s is equal to minus 1 over to the power of n into t of n f of t. I have already told you that very simple formula, which is the Laplace transform of t to the power of n into f of t is equal to minus 1 over to the power of n into nth derivative of f of s with respect to s. So you can do the same procedure to get this value. Suppose the Laplace transform of sin mt is nothing but which is m by s square plus m square. So I am going to assume f of t, then it will become f of s. So now the Laplace transform of sin mt by t is nothing but, if suppose, see, then for this one we are going to go for the t. So therefore I have already told you, which is s to infinity f of s into ds, which is s to infinity f of s value is m by s square plus m square into ds. So therefore here now what we are going to do is, m is a constant value, so we are going to take it outside. Then the integration of 1 by a square plus x square dx is nothing but 1 by a into tan inverse x by a. So by using that formula, we are going to get 1 by m into tan inverse s by m into. So now you have to substitute the limits s to infinity. As these are same, so now we are going to cancel these things and substitute the upper limit minus lower limit. We are going to get tan inverse of infinity by m minus tan inverse of s by m. But tan inverse of infinity is nothing but im. It is a 90 degree, so pi by 2 minus, and it will become tan inverse of s by m. So now what I am going to do is, here I am going to convert this into the general expression, which is t is equal to 0 to infinity. Here f of t is this value, which is sin mt by t into e to the power of minus st into dt. So this value we are going to get finally. So now what I am going to do is, I am going to substitute s is equal to 0, and also I am going to substitute m is equal to 1. If these two conditions are, I am going to substitute, then this will become 1, and here also this will become 1. So sin t by t dt integration to 0 to infinity is nothing but, here substitute here s is equal to 0, so tan inverse of 0 is again 0, and this will become pi by 2. So therefore answer will be integration of t is equal to 0 to infinity sin t by t dt is nothing but pi by 2. Tan inverse of 0 is nothing but 0 degree, whereas tan inverse of minus 0, see, it's a very important thing, tan inverse of 0 will be always 0 degree, whereas tan inverse of minus 0 will be, it is plus 180, because you can see clearly in the tan function. So you can see clearly here, this is a tan function. See, this is 0 to pi by 2. So at pi by 2 it will become infinity, whereas again pi by 2 here means pi. So therefore you can see clearly a tan inverse of 0 is nothing but 0, whereas tan inverse of minus 0 will be nearly equal to 180 degree. So plus 180 degree. So now what I am going to do is, here, see, for the same above formula, now you can see clearly here one thing which is very important, which is, suppose t is equal to 0 to infinity sin mt by t dt. Then what I am going to get here, for m greater than 0. If suppose, if I am substituting s is equal to 0, S is equal to 0 means tan inverse of 0 by m. If m is greater than 0 means 0 by anything positive is again 0. So therefore we can say it will become 0. So pi by 2 minus 0 is pi by 2. But if m is less than 90, if m is less than 0, so therefore 0 by any negative value is nothing but minus negative value is minus 0. But tan inverse of minus 0 is plus 180. So 90 minus 180 is nothing but minus 90 degree. So therefore minus pi by 2. It's a very important thing, which is for m greater than 0 it is pi by 2. For m less than 0 it is minus pi by 2. Because here 0 by positive value is again plus 0. So whenever it is a plus 0 it is 0 degree. Whenever 0 by negative value which is nothing but minus 0 which is plus 180. So pi by 2 minus 180 is nothing but minus 90 degree. So therefore it's a very important thing. So for tan inverse of 0 which is 0 degree, whereas tan inverse of minus 0 will be plus 180 degree. So by using that we are going to solve this equation. Suppose there is in question, suppose there is like this one which is 1 by s square into s plus 1. So now I am going to convert into fractions which is a by s plus b by s square plus c by s plus 1. So now the LCM of this thing which is s square into s plus 1. So for a we have to multiply by s into s plus 1. For b we have to multiply by s plus 1, and here we have to multiply by c s square. So now what I am going to do is I am going to compare in terms of s square. So after that by rearranging we are going to get this expression. So now we are going to compare the numerators of this one and this one. So by using that we can solve the equations to get the values of a, b and c. By matching the coefficients, so a plus c should be equal to 0 and a plus b is equal to 0 and b should be equal to 1. So by solving this one we can get the value of this coefficient values. So therefore this overall function will be equal to like this fractions part. So sine of a plus b plus sine of a minus b will be 2 sine a cos b. It's a very important trigonometric formula. Suppose there is also some more complex function like this one which is k by s minus a into s minus b whole square, s square plus cs plus d into s square plus es plus f whole square. So now I am going to convert this complex function into some of the fractions, which is the first thing is here a by s minus a, and here b by s minus b plus c by s minus b whole square, plus it is a second order, so therefore we are going to get ds plus c by s square plus cs plus d, and this is also second order, so therefore again same like this one, fs plus g by s square plus es plus f plus hs plus I by s square plus es plus f whole square. So now do the take the numerator values. Now you can compare them and you can figure out the value of a, b, c, d, e, f, g, h, I. So you can figure out all these complex values, you can easily figure out. And similarly, suppose there is a function like this which is y of s is equal to s plus 5 by s plus 2 whole square. So I can convert into a simple fraction which is a by s plus 2 plus b by s plus 2 whole square. So now I can compare the numerator parts and finally I can get the values of this constant a and b, and I got the value of a is 1 and b as 3. The Laplace transform of e to the power of it, if you want to figure out which is e to the power of it is cos theta plus I sin theta. So if you want to know the Laplace transform of this one, then you have to go for Laplace transform of cos theta and also I into the Laplace transform of sin theta. Then only you can get the value of the Laplace transform of e to the power of I theta. The solutions of Laplace equation having continuous second order partial derivative is del square phi is equal to 0. See, the solutions of Laplace equation having continuous second order partial derivative is del square phi is equal to 0, and I have already told you that this is nothing but a harmonic function. So therefore, or simply we can say dou square phi by dou x square plus dou square phi by dou y square is equal to 0. Then we can say phi is said to be a harmonic function. See, I have already told you in the that complex variables which are whenever a function is analytic function, by default we are going to get that u and v are harmonic functions and also they are orthogonal to each other. These are the things we are going to get whenever a function is a analytic function, means it is defined at each and every point in a given range of things. So therefore, whenever these are going to get satisfied, so we say that the function is said to be a harmonic function. So at the point of discontinuity, the Fourier series converges to, see whenever, so you can see any periodic function, sometimes there will be a discontinuity in the graph. Then, but at the discontinuity, you can't say what is the exact value, but the Fourier series expression is going to give you the exact value. So what is that exact value is nothing but, which is, suppose there is a t0, there is a discontinuity in the graph. So therefore, f of t0 is equal to half of f of t0 plus f of t0 minus, means these values you should figure out from the graph and do the summation and then do the average of this value. Then we are going to get this Fourier series is going to give you this exact value. But actually in the graph, you can't say the value because there is a discontinuity. But this Fourier series is going to converge to this point at that discontinuity at, let me assume, t0. So therefore f of t0 plus and f of t0 minus, you should get these values from the graph. Suppose there is a function g which is f of x minus cy. Then I want to do a partial derivative with respect to x, which is dou u by dou x is equal to f dash of x minus cy into 1. Suppose if you want to do with respect to y, the partial derivative which is dou u by dou y is equal to f dash of x minus cy into minus c. So this is a very important point. See, for a causal LTI system, always y of 0 is equal to 0 and y dash of 0 is equal to 0, because for a causal LTI system means even if the input is 0, output should be always equal to 0. So therefore initially the system is at rest. So therefore the output can't change instantaneously. So because of that reason, y of 0 is equal to 0 and also y dash of 0 is equal to 0 at the initial condition. So now we are going to learn about the Fourier series. Suppose there is a function f of x. Suppose any general periodic signal, suppose there is a function f of x, it is going to have some period, let me assume the period is equal to 2l. Then we can say simply f of x plus capital T is equal to f of x, because the period of that function is nothing but capital T. So therefore now, how to write the Fourier series of any periodic function? So therefore now what you are going to do is, the Fourier series general expression which is f of x is equal to a naught plus sigma n is equal to 1 to infinity an cos n pi x by l plus bn sin n pi x by l. Then how can we write into, then how to figure out the values of these constant values? We can say this coefficient values how to figure out, which is a naught is equal to 1 by total time period into integration of overall time period into f of x into dx. And if you want to know what is the coefficient of an, which is 2 by time period, so overall integration across the one time period into f of x into cos this value, which is cos n pi x by l into dx, then can go from 1, 2, 3 up to infinity. And similarly, if you want to know the coefficient of bn, the coefficient of bn, which is here 2 by overall time period into integration over the time period, which is f of x into the sine value, which is sine n pi x by l into dx, n range from 1 to infinity. So with the help of these things, we can figure the value of a naught, an and bn. So this is very important formula. This is a Fourier series in the terms of cos function and sine function, and these are the coefficients in order to figure out from this function f of x. So now we are going to see some simplified versions. Suppose if f of x is an even signal of time period t is equal to 2l, then what is going to happen? Suppose if the signal is a periodic and also it is an even signal, means f of minus x is equal to f of x with respect symmetric with respect to y-axis, then what is this Fourier series coefficients, what they are going to become? Then we are going to see here, as I have already told you, a naught is nothing but which is 1 by overall time period into integration of overall time period f of x dx. So instead of doing over the overall time period, we can do half of the time period because it's a periodic function. So therefore 2 times of 2 by capital T over the half time period into f of x into dx. Whereas an is nothing but here the initial formula is 2 by overall time period into integration over the time period, and also here f of x into cos n pi x by l dx. And cos function is also even and f of x is also even. So even and even is again a even function. So therefore this overall function will be even function. So therefore no need to do over the total time period. We can do only half of the time period. So therefore if you are going to do half means you have to go for the into 2. So therefore finally you are going to get this value. So where n ranges from 1, 2, 3 up to infinity. Whereas bn, here for bn there will be f of x and sine. Where f of x is even, sine is odd function. So the product of even function and odd function will be odd function. So therefore integration over the time period for odd function will be always going to give you 0 result. So therefore this value will become 0. Means there will be no sine terms. Only even function or even signal will have only the constant part and only the cosine terms, but there will be no sine terms. Therefore now the Fourier series will converge to a very simplified version, which is f of x is equal to a naught plus sigma n is equal to 1 to infinity an cos n pi x by l. Suppose what is going to happen if f of x is the odd signal of time period t is equal to l. But for odd signal, definitely I have already told you, which is a naught is equal to 1 by overall time period into integration of over the time period f of x dx. So integration of odd signal over a one complete time period will be always going to give you 0 result. So therefore a naught is equal to 0. And similarly an is equal to 2 by time period into integration over the time period f of x into cos n pi x by l into dx. As f of x is odd and cos is a even. So therefore the product of odd and even is going to give you result of odd function. So over the integration of over that one time period odd function, the result will be 0. So because of that reason only this an value will be equal to 0. Whereas bn is equal to 2 by over a time period into integration over the time period f of x into sin n pi x by L into dx. Whereas sin is an odd function and f of x is an odd function. So the product of two odd functions is going to give you even function. So no need to do over the complete time period. Then we can do only integration over the half time period. So therefore you have to go for the external number 2. Then you are going to get this is the expression where n ranges from 1 to 3 up to infinity. So therefore for odd function definitely the constant part is 0 and the cosine terms are also 0. So therefore only sine terms are going to get present. So therefore now the Fourier series is going to converge to a very simple version, which is f of x is equal to sigma n is equal to 1 to infinity bn sin n pi x by L into this is the value we are going to get. Now we are going to see some of the important extensions. Suppose even cosine series extension. Suppose in the exam they have given some function f of x. It is defined in only 0 to L. Then they are asking about the try to expand in terms of the cosine series. In the exam they are going to ask you. Then what you have to do is you have to assume another function which is capital f of x is equal to f of x for 0 less than x less than L. But same function we have to go for the symmetry with respect to y-axis. So therefore f of minus x. So f of x is equal to f of minus x. So therefore we are going to get the same function from minus L less than x less than 0. So therefore we are going to see with the help of this small function f of x we are going to build another function f of x which is a periodic with respect to y-axis. So therefore now we can say this is a periodic function or we can say it is an even signal. So therefore now time period is f of x plus 2L is equal to f of x. I have already told you a naught is equal to here 1 by time period integration over the time period f of x dx. But here it is an even function. So therefore now what we are going to do is we are going to do only integral with respect to half of the time period, which is 0 to L. But for 0 to L the function divided is small f of x, and also here you have to go for the external factor 2. Then you are going to get the value of a naught. Similarly an is nothing but here 2 by over time period into integration of over the time period f of x into cos n by x by L into dx. This is an even function and this is also even function. So the product of two even functions is again even function. So no need to do over the one time period. So therefore you can do only half of the time period. It means 0 to L. So in 0 to L the function defined is small f of x. So you have to go for the external factor of 2. So n can range from 1 to 3 up to infinity. Whereas bn is nothing but for bn this is an odd function and the sign is a see f of x is an even function whereas the sign is odd function. The product of even and odd we are going to get the result as odd function. So integration of any odd function in a complete time period will give you 0. Therefore bn is equal to 0. So therefore now with the help of this one we got capital f of x is equal to e naught plus sigma n is equal to 1 to infinity n cos n pi x by L. So now with the help of small f of x we have built a even function, or we can say even function. Then we got the value of the f of x in terms of cos series. Now, suppose in the question they are going to ask you odd sine series extension. So they are given small function f of x is defined in this range and they are asking us to figure out the value of the sine series. Then what you have to do is we have to build an odd function definitely, which is capital f of x is equal to f of x or 0 less than equal to x less than equal to L. So therefore it will be minus of f of minus x. So therefore minus L less than equal to x less than equal to 0. So with the help of this small f of x we have built a basically an odd function with respect to y-axis. So then the period of the function is very simple, which is a 2L. So therefore f of x plus 2L is equal to f of x. I have already told you for an odd function definitely a naught value is 0 because integration for one complete integration of any odd signal will be always going to give you 0. Similarly an is nothing but it is a 2 by over time period into integration of over the time period f of x into cos n pi x by L into dx. Whereas f of x is odd and cos is even. So the product of even and odd and even is nothing but odd function. So therefore the integration over the one complete time period of odd function will be always going to give you result as 0. And similarly bn is equal to, which is 2 by overall time period into integration over the one time period here f of x into sin n pi x by L into dx. But here f of x is a odd function and sin is also odd function. The product of two odd functions will be always an even function. So no need to do over the complete time period. So you can do only half of the time period. For 0 to L the function divide is small f of x and you have to go for the external factor of 2. Then you are going to get, this is the expression we are going to get. So therefore n is equal to 1 to 3 up to infinity. So you can see clearly there is no constant term, there is no cost term, only sine terms are going to get present. So therefore now the capital f of x is equal to sigma n is equal to 1 to infinity bn sin n pi x by L. So this is the way we are going to convert. So they are going to use small f of x and they are going to ask you cost terms or sine terms. Then if they are asking about cost terms means we have to build the function as even. If they are asking about the sine terms means we have to build the function as odd. and then you can figure out the Fourier series of that expression. You can easily figure it out. So these are some of the important formulas of Laplace transform and also Fourier series. These are generally asked in the examinations. So I hope if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever you upload a new video, the direct notifications comes from mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. Thank you so much for watching this lecture. Keep smiling, take care, and bye bye.